We are at chapter 16.4 from textbook, page 338. It's absolute motion analysis. So, at the end of the class, students should be able to determine the velocity and acceleration of a rigid body undergoing several plane motions. So this is where the key is. You got few combination of motions, and you get them all connected with one equation. So that is the motive or objective of this lesson. Okay, so example, the dumping bin on the truck rotates about fixed axis passing through the pin A. So you see here A, there is a rotation. It is operated by the extension of hydraulic of BC. So BC is the hydraulic extension. So the angular position of the beam can be specified using the angular position of coordinate theta and the position of C. So the whole chapter, the objective of this chapter is to get B connected to A and connected to C via equations. Series of equations. Like example, this movement here. You have got a linear movement and you also got a curvilinear movement. If you see AB, it's moving curvilinearly. So, but then to get A connected to B and connected to O, this is where we are coming to this particular chapter. Likewise, from A to B, B to C. Okay, this combination, this thing is moving straight, this is moving linear. Now, if you want to see whether it's linear or not linear, sometimes it's a bit confusing, isn't it? When you look at it, you say, I don't know where is it moving. You have to imagine. You have no choice. And if in the textbook you see here, they will give you the final and initial dot. You just have to join and extend a bit. So you know that this is linear. Okay. What about this? You have the initial and the final dot. Join them and extend a bit. So you know it's curvilinear. So a bit of imagination is required. Otherwise, it's very difficult for you to actually solve the questions. Okay. This is a very good slide. Okay. Very good slide. Actually explaining between A, B and C what is actually happening. So you can just read through them. Okay, so the procedure is that you first thing you locate the body using the correct position coordinate measured to the fixed origin. You need to know where is the reference line. Okay, based on that you get them all connected. Take the first derivative to get the relationship between V and omega. That's very important. From here you get between alpha and A acceleration. Okay, so I'm going to go through an example of the textbook. You can just go through this example, group example and thing. It's a bit simple, easy to understand. Now this is a bit challenging, so just pay attention. Okay, the end of the rod R, so the R here, maintains contact with the cam by the means of the spring. So you have a spring here. If the cam rotates about the axis, so where is the axis of this cam? It's very unique. The axis is actually here, O. So which means if the cam goes up this way, the length here is not uniform. The length that this thing will get extended is not uniform, because if the axis is actually right in the middle, then you have the the rod having the same spring extension at all the time, because if this thing is rotating. But now the problem is it's not rotating in the middle, it's rotating at the point here. So if this thing to drop or if it move away, so the length will not be uniform. It's not R. It's not R. So you have to pay attention at this point of time. So it is not just R, but it is X value. So what is the X value? It is 2R. Because when you drop this, R cos theta is the distance from here to here. The distance from here to here. So we have 2R cos theta because it is twice here and here. So 2R cos theta. So this is your X. So going back, I haven't even finished reading. If the cam rotates about the axis through O, the angular velocity is alpha and omega. Okay, determine the velocity of acceleration. Cam is in arbitrary position theta. So they want you to find value at theta. Okay, so you can understand what I've explained earlier. So I'm just erasing that so that it doesn't look messy. So now you understand why it is X equals to 2R cos theta, right? Because Here is r, distance r. When you drop here, it is 2r. R cos theta. This is r cos theta. But it's twice the distance, so that's why it is 2 r cos theta. Okay? So using the chain rule of calculus, yeah, your calculus should be good. Using the chain rule, you can actually differentiate these and find for the v. Okay, because reason being, because this is x in r, yeah, but you have to actually differentiate with time, so that's why it's unique. You have to use the chain rule. You get your v and you differentiate these, yeah, you get your a. So you have solved the question. Okay, because this is mostly mathematical. You can just do it by yourself, yeah. If you're not sure, then you have to ask the mathematics lecturer for the detailed working of a chain rule. Okay, so with that, we have actually solved this question. Now if you look at this carefully, if you see, they are actually getting the r connected, isn't it? The r, they just want to find what is the distance, yeah. How is it getting connected to acceleration, velocity? So this is what the chapter is all about, yeah, getting one to connect to the other. Now if you remember, I've been also telling you many times that you need to actually visualize the movement. Visualize the movement. If you can't visualize the movement, then you're going to have really big trouble in answering the question. What I meant by visualize the movement is, of course, this drawing is done, right? But you need to know, if let's say this goes up here, what actually happens to the distance here? Okay, it's getting shorter and shorter and shorter, isn't it? This distance gets shorter, and the r distance gets longer, so the spring gets longer, correct or not? Yeah. What if it goes down? Then the distance of x becomes longer, yeah. Okay, just now was shorter, then it will get longer, and the spring will get compressed more. So you need to visualize that. Yeah, that's very, very important. Yeah, the visualization is very, very important. This is from page 339 of the textbook. Okay, so now I'm going to just move on to the next part of the chapter, which is 16.5. Yeah, 16.5, which is the relative motion of analysis. Velocity. Okay, so describe the velocity. At the end of the day, students must be able to describe the velocity of rigid bodies in terms of translation, rotating component, and perform a relative motion, velocity analysis of the point on the body. Okay, so this is also to actually find connections, yeah, but now we're looking at velocity. Later we'll be looking at acceleration. Yeah, as a slider block A moves horizontally to the left at speed of VA, it causes the link CB to actually rotate. You see, CB is rotating counterclockwise, so VB is directed tangent to the circular path. So which link undergoing general plane motion? So link AB or link BC, yeah. So how can the angular velocity omega and the link B be found? So at the end of this chapter, you'll be able to answer all this question. Okay, now in a gear system, planetary gear system are used in many automobiles' automatic transmission. By locking and releasing different gear, this system can operate the car at different speed. So in a gear system, always remember, yeah, always remember. So this is one gear, gear A, and this gear B. If let's say they're touching tangentially, then the velocity at that point will be the same. The velocity is the same, not the omega. Omega will only be the same if let's say you are starting from the same axis. It means the rod between gear A and gear B is the same. So if the rod is same, then the omega will be the same, but not the linear velocity. Okay, not the linear velocity. Linear velocity is dependent on the r value itself. Can you see that? Yeah, the r value, different r value will give different linear velocity. Okay, can you understand? As long as it's touching here, then the v is the same. Yeah, this has got different omega, this has got different omega, because they are two different axes. So this is something that you need to actually understand on gear system itself. Yeah. Okay, now let's moving on to the relative motion of analysis. Yeah, when a body is subjected to general plane motion, it undergoes a combination of translation and rotation. Let's look at this rod AB. Yeah, look at this rod AB. So now it's moving to a new position. So when it moves to a new position, what is actually happening here? There is a translation and there is a rotation combination. Okay, so if you look here, drb equals to dra, this one equals to drba. Okay, this is the displacement due to the rotation. So this is the derivative, okay, derivative of the formula. When you differentiate that once, you get vb equals to va plus vb stroke a. So what is vb stroke a? It is omega multiplied with rb stroke a. Yeah, okay, do not worry much, we're going to solve a question so you will understand even better. Yeah, so this is how the final formula will look. Okay, now procedure for analysis. So the relative equation can be used can be applied using the scalar x and scalar y component via the Cartesian vector analysis. So for scalar analysis, so we look at both, yeah, scalar and also vector. You establish the xy coordinate, you draw the kinetic diagram, and then you write the equation. And in the kinetic diagram, you represent the vector graphically with the magnitudes and directions under the each term, and then you write the scalar equation. Whereas for the vector, of course the same, you establish the coordinate, you draw the kinematic diagrams and also the kinetic diagrams, and then you express it in the Cartesian vector form. Yeah, Cartesian vector form, and then evaluate the cross products. This part is actually cross product, and if the solution yields a negative answer, the direction is in the opposite side. So let's solve a question from here. This is very simple question, you can just go through by yourself. Yeah, I'm going to go straight to example 16.6 from the textbook. Okay, this can be a bit tricky, so I want you to actually pay attention. There are two methods to actually solve: solution A and solution 2, vector analysis and also scalar analysis. I don't actually encourage students to use scalar analysis because sometimes when the question gets very complicated, it's actually very difficult, yeah, to find especially the axis, which axis, I, J, or K, or X, Y, Z, which axis. So when you put it into a vector analysis, you write your unit vector I, J, K. It's very easily defined that which axis it falls in. It's a bit easier. So that's the reason why I don't actually encourage in scalar analysis. Okay, let's concentrate only on vector analysis. Yeah, vector analysis, because it's very well defined and it's really very easier to visualize and also look at it. Yeah, okay, let's look at this link here. The link shown guided by the two blocks A and B. So we have block A and block B, yeah, which moves in a fixed slot because they move in a fixed slot. Velocity A is 2 downward, and velocity B, so you have to determine the velocity B. Okay, what's given to you is the link's distance, the angle of rotation, yeah, and if you see here, this thing is moving straight downward. VB is actually moving here straight. This whole thing is actually rotating. Okay, yeah, it's a bit complicated to actually look at it and know whether it's rotating or what, so the best thing to do is actually to draw dot lines and join them. So when you join them, you will see that it's actually rotating. So I'm just going to erase all this so that you understand, you can look at it. Yeah, okay, so what do you have here? Determine block B. So they want block B. Okay, from the standard equation of VB equals to VA, this part is the VB stroke A, yeah, which is as opened up already. Yeah, opened up already. So we look at the opened up formula. So now we start plugging in the value. VBI, draw the diagram, So if you draw the diagram and also the motion diagram. So in the motion diagram, there's nothing. There's no acceleration in any angle. So you just leave it empty. Okay. So from this diagram, now the next step is to solve the question. Yeah. From the diagram, the next step is to solve this question. So VB, where is VB? Is in the I direction, just right there. VB in the I direction. Okay. So where's the VA? VA is in the Y direction. Sorry, this is in X direction. Yeah. So that's why it's I. Okay. So this is in Y direction. So that's why it is 2J. Now why is the negative? Because it's pointing downward. Okay, pointing downward, you take downward as negative. Okay. Now omega. From the cross product, yeah, you know that the omega will be K. It will, if you have IJ, it will be the third axis, K. Okay. Now RB stroke A. How do you get to this? Yeah. RB stroke A will be the length 0.2 sine 45 and cos 45. If you see, can you see the length here? 0.2. Yeah. So you can actually resolve this into x-axis and y-axis. Yeah. Because you know the angle is actually 45. The angle is 45. So when you resolve it to the x-axis and when you resolve it to the y-axis, okay, this is what you get. I and J. Okay. Okay. Now why is it sine 45? Sine 45, yeah, the angle is down here, so sine 45 is somewhere here. Okay, it's positive because it's pointing this way, and this is negative because it's pointing down. Okay, so now when you solve this mathematically, so what do you get? You get VBI equals to negative 2J 0.2 omega sine 45 J and then 0.2 cos 45 I. So your next activity would be to actually look out. You take the I and you compare with only the I. Can you understand? Yeah. So that's why vector analysis is better. And if you look at J, so you would only compare with J. Can you see that? So that's why you have the J here, and then you have the I, X the other side. So with this, you can actually solve the equation. Okay, so that is the method in solving the relative motion analysis of velocity. Okay, so with that, I have completed this part of the lecture. I will see you in the next lecture. Thank you.